Hello class, and welcome to today's pre-algebra lesson, which is about proportional relationships and direct variation. By the end of today's lesson, you will be able to identify proportional relationships as well as write direct variation equations. So, proportional relationships mean that the ratio of each y value to its x value is constant. So what that means is every time you take a y coordinate and you divide it by the x coordinate, the answer is going to give you the same number. This means that our rate of change, so the difference in between the points, is constant, and that it will always include 0, 0 on the graph. So our first job is to be able to identify proportional relationships. When they are on a graph, your job is to determine first if it is a straight line. If it is not a straight line, then it is automatically non-proportional. If it is a straight line, like this one is, it must include the point 0, 0. So this example would be proportional because it is a straight line that includes 0, 0. So we have the fact that it is straight. It needs to be straight in order to be proportional, and it includes 0, 0. So that coordinate must be on the graph. If, for example, you had this line going right here, it is a straight line. However, it does not include 0, 0. So that second line that I just drew in, this top one, would be an example of non-proportional and what that looks like on a graph. Coming over, the other way we can identify proportional relationships is in a table format. When we do that, we are using that y over x equaling the same answer idea. So I would check my first pair and I would say 4 over 1. That's going to equal 4. Jumping to my second pair, I have 6 over 2, which is equal to 3. So this is non-proportional. As I check those ratios, it is not a constant value. You don't have to give a because part as long as you are showing your work for the table. If, for example, this 6 had been an 8 and 4 over 1, 8 over 2, and 12 over 3, those would all have equaled 4, and then it would be a proportional relationship. But right now, since when we put in 2, we get out 6, it is non-proportional. Next, we're going to look at graphing these proportional relationships. When we do that, we want to create an XY table. The first thing that we are going to put into our table is 0. So we're doing 3 times 0, which is 0, and we put that point on the graph. So that is 0, 0. Then we're going to go 1. So 1 times 3 is 3. So my next coordinate is going to be right 1 and up 1, 2, 3. My next coordinate then would be 2. 2 times 3 is 6. So I go 2 to the right and 6 up. Then I go 3. 3 times 3 is 9. 3 to the right and 9 up. At this point, we have completed the graph because we have run out of space in our particular picture. Then we need to connect it with a straight line going through all the points. And we put arrows on the end of our line to signify that even though our graph picture is done, this line would continue going on forever in both directions. So in order to complete the graph, you have to fill it out as far as you can possibly go. In this case, that meant there was 4 points on the graph. Sometimes there might be 3 or 2 or 1, or there could be more than 4, depending on what your relationship is. The last piece here is direct variation. This is a relationship where the ratios where the ratio of two variables is constant. This is taking the idea of proportional and turning it into an equation format. So direct variation is what we call the equation version of proportional relationships. Once again, it has to pass through that origin. It's going to touch the point 0, 0 because it is a proportional relationship. And our key here now is the equation, which is going to be in the format y equals kx. In order to find that value of k, we are using that fraction format that we had to determine if things are proportional. So we're going to start by looking at it from the graph. So it tells us that the cost of apples vary directly with the pounds of apples that you buy. Again, we know that it is direct variation. 1, because it says in the sentence, and 2, because it touches 0, 0 on the graph. Now we need to use our graph to write the direct variation equation and then determine the cost of 5 pounds of apples. So to start with writing our equation, your job is to pick one coordinate pair out of the graph. I'm going to just use this first coordinate pair here. When I do this, I need to set up to find my k value. So I'm going to take my y value, which is 0.40, over 0.50. When I divide those, I find that my k value is equal to 0.8. So my equation then becomes y equals 0.8x. We take that k and we put it into our equation where k would go. So that is the first step to solving this problem. The other part then asks you to calculate how much it would cost for 5 pounds of apples. Pounds is an x value on our graph. So I'm going to say y equals 0.8 times 5. When I solve that, I find out that my cost would be $4. Make sure you are including your label on that final answer, saying that it costs $4. In this next example, it's the same kind of idea, but now instead of getting our information from the graph, we are getting it from a sentence. So it says the cost of purchasing peanuts at the grocery store varies directly with the weight of the peanuts. Again, telling us it is direct variation. At Jerry's, 2 pounds of peanuts cost $5.80. Go ahead and use this information to find the k value. So we find that our k value is 2.9, meaning that our equation is y is equal to 2.9x. Then it asks you to determine the cost if you purchase 13.6 pounds of peanuts. So go ahead and calculate that cost value on your own. So when you plug 13.6 pounds into your equation, you find that your final cost is $39.44. Our last scenario here is the same kind of idea, but now we are getting our information out of a table. Again, it tells you that the time it takes to download an app directly varies with the amount of information, aka the size of the app. Our first job is to write that direct variation equation. So you can pick out any of these pairs, so 2.5 and 10, 3.75 and 15, 10 and 40, 25 and 100 to find that k value. Go ahead and solve that part on your own. So we find out that our k value is 4, meaning that our equation is y is equal to 4x. Now it asks us how long it will take to download a 700 megabyte app. So go ahead and do that calculation on your own. So when you finish solving, you find out that it is 2,800 seconds or 46 minutes and 40 seconds if you prefer to convert it to that other unit. You do not need to do that, but it is an option for this one. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.